Hey everybody, and this is Sofox, and I'll be looking at the Arduino Starter Kit, and specifically I'll be doing the first activity. Now, just a quick recap, the Arduino Starter Kit is basically, well, I've already opened this, but it's essentially an Arduino and a bunch of accessories and things that you can actually use to, have it do stuff. And among the other things it has is a book that basically gives you a whole load of activities and stuff you can do with it. So essentially, there's several different projects. I think I'm going to start with just doing the first one, the Get to Know Your Tools one. But before I can do that, I have to do this little thing here, which basically involves getting the wooden out. So you take this, take the wood sheet and carefully separate the pieces. Okay. So we take this bit here. Okay, get until you've separated all the parts. That looks like this. Place the pieces marked with an A onto the holes in the corners in order to create the feet of the base. This says A on it. Okay, so those seem to be the feet of the base, all right. That seems to be good, and that seems to match up more or less there. Yeah, if it was that side, it wouldn't work. Okay, secure your Android Uno to the base using 3 screws. Be careful not to over-tighten. So, I think by this stage I turn it right way up. I need to put this somewhere here. Yep, there we are. No, wait. There. Okay, maybe I did put it on the wrong side after all. Alright, so this goes here just like the etching seems to show. And now I need to find the screws. So where are the screws? Well, I can't find the screws. Well, this has been a very short presentation. I'm just joking, Wait. There's something here that looks like a screw. They've cunningly disguised the screw among a huge amount of other things that also are tiny and very easy to miss. So, let's move this back in. According to this, we just put these in topside first. Oh, there we go, I think. Alright, there we go. There, I think, is the second screw. Okay, these screws aren't really, like, secure to anything. Oh, wait, yes, of course. They have little hex bolts, little these things, so that the screws actually work. Okay, I was wondering for a second there. Technically, you're meant to use a screwdriver, but yeah, you don't want me spending the next 5 minutes reading for one, even though. Okay. Besides, using a screwdriver to tighten bolts right up against sensitive electronics doesn't seem like the best deal for me right now. I might do it a little later if it takes a while. Or if it gets loose. Okay, so I've got the last bolt. And all I need is the last screw. Okay, we've got the Arduino secured to the board. Now, as we can see, we carefully peel back the breadboard and we stick the breadboard next to the Arduino Uno so that where everything is nice and neat. Now I need to make sure I put the right side. Oh wait, it looks like it doesn't matter which side you put it on. They're both, it's completely reversible either way, see? Okay. Oops. There we are. Now, carefully. And there we go. Okay, so with all that bit of minor drama, let us move on to the next step of the book, if you look at the contents, oh, this is chapter 0, very cute. So it's all just miscellaneous stuff and telling you about the bits like the gels and the LCD display and or the LEDs, diodes, DC motor, capacitors. This has actually got quite a few nice little components in it. I kind of bought it more for the components, but finding the guides just in a little bit of fun as well, and to give you some cool things to do. So as you can see, we've got the power cable there, which I'm feeling is going to be next. But more to the point, we're moving on to our first chapter, getting to know your tools. Oh, that's the spaceship interface. We'll be doing that next time. So, basically, this is electricity. Electricity flows from positive to negative, which is actually a complete lie, but let's not shatter their illusion right now. It goes from there to there. This is a breadboard. Breadboards are pretty straightforward. All at the sides, they're vertically connected, and in the middle, they're in rows. So you can see the same thing just there. You know, vertically, the ones on the side are fine, and then these ones are all just little rows. So, and you can see even on this breadboard, they mark plus and negative, so you know which ones to go. Which one is which. So the first thing to do is plug this into your computer. You get the cable ties off. Okay, one end into your Arduino, one end into the computer, and hey, it's alive. Congratulations, we've created life. Now you can create all the short circuits you want. No, seriously. So let's just quickly skip ahead. A lot of the Arduino stuff involves like programming stuff, but we're going to start with just a simple LED lights. This will just be using like the voltage and the ground. Yeah, that's right, yeah. 1 into 5 volts, 1 into ground, and go from there. So, we go back to these things. We're going to use the red ones because it's so much easier to know that it's red. I like the way these wires are like pre-bent and everything. And we put one, if you look closely, it says 5V. So we put one in 5V and the other in, oh, sugar, it's not long enough. Let's try again. Use an orange one this time. One into 5V and the other into, oh, now it's too, come on, seriously. Well, these things are I mean, I could use a color that's not red or orange, but the whole point is that by keeping it color coded, you know what is, screw it. I'll just use a long one and then just force it in. It's not like these wires can't be bent, it's just, thought we could get away without having to do that. Oh well. Okay, so this plus row is all wired up. Now we just have to find the, you can see this now. There's the plus. So that means all this column here, the very leftmost column, is all positive. So let's link it up with a negative. They don't seem to have any black wires, so I'll just use a dark green one. Oh, these are really long. You know what, screw it. I'm going to break tradition and use a red wire to use negative, which totally doesn't make any sense. Oh, wait, this isn't even long enough. Okay, never mind. I'll just use another orange one. See, the thing is, if they weren't stuck so close together, I'd just move them apart or closer and think, hey, my job's done, but you know, I just have to be all OCD about it. Okay, so this column is now plus, this is all negative. Now, if I want to blow this thing instantly, what I do is I just stick this in right now. You know, one to positive, one to negative. Oh, it's not working. Well, that's weird. Oh, right. I made a mistake. I put them both into ground. There we are. Okay, So if I want to do this, you can just do it right now. Come on. There we are. Now I only did that very, very briefly because the key thing about these is you don't want to put, this is the full voltage, 5 volts going straight through this, straight this, and then back. So it can overload it. So what you're meant to do, like if you're an intelligent, responsible, and cool person, is that you're meant to actually put a resistor between it. Now they recommend this resistor, which is red, brown, and I'm pretty sure they've got a. They give you some diagrams so that you can decode what voltage, what resistance a resistor is, because they are color codes. And I can't find the color codes right now. Okay. Oh, there we are. Yeah. So red, brown is, I believe, 220 volt amps. So let us find a red, brown one among all these little things here. Yeah. There's 20 kilo ohm and 220 ohm. So I think this is the best. This is brown, black, and orange, and gold. And meanwhile, this is red, blue. Oh dear gosh. What is up with these? According to this, there's 20 of these about and 20 of these. So one of them should be the 220 ohm ones and one should be the 10 kilo ohm ones. So let's try to decode which ones are which, because neither of them are red, brown or anything like that. Okay. Okay, so you find out which side the gold band is on and you start from the other. So this is brown, black, and orange. So brown is 1, black is 0, and orange is 3, which means that these must be the 1 kilo ohm, the 10 kilo ohm, because that's 10 multiplied by 10 to the power of 3. Whereas meanwhile, these are red, something else. Red sounds like two. Okay, we'll just assume that these blue ones are it, because even though it doesn't make sense, I'm just gonna have to. Yeah, I think red something. Screw it. We're going to assume that these blue ones are the 220 volts because, like I said, there's only 2, according to the ingredients, there's only 2 of these that have 20 in them, and I can't really make it out. It's definitely red, and something, but the middle band is way too hard to make out. So, let us go back to actually doing what this thing is meant to do. So, as you can see, you basically connect a resistor to the breadboard, then connect one to the LED to one, the other side to the other, and then connect it back. So, let's connect this end to, shall we say, row 5. Now, one important thing that you may miss about LEDs, they are, the shorter one is always negative, and if they're so bent you can't tell it, there's always a slightly flat thing right here that you can tell which that faces the negative side. So I put the longer one in here, so it's in connection with the it connects to this resistor, which connects to this side, which means it connects to the negative. But we need one more in order to get this whole thing working, and that is we need a connection from the as you can see, it's on the positive is row 5 and the other side is row 6. So we'll connect row 6. Ah, we got a black one, almost, well, dark purple anyway. 6 to, no, not the positive, well, that won't really, but to the black row, to the negative. Oh, there we are. Okay, so there we have it. There we've got a circuit, one of the most basic things you can do. Now, like I said, if we could see about programming things, but this is just getting to grips with it. So that one's that one complete. Oh no, not that one. That one's that one completed fine. Which, as you can see, is here. Next step is to throw in a switch because, you know, smart people actually have control over these things. So the idea is pretty straightforward. Yeah. We'll take this out and we'll find a switch, which I know is around here because I had to like pick it up and throw it back onto the table a second ago. There we are. Now the key thing, and then we put this switch here. Now the key thing is the top two are always connected and the bottom two are always connected. But when you press the button, the top row and the bottom row get connected to each other. So if we put this here, I said if we put this here, yeah, there we are. So now when I click this, this row number 5 gets connected directly with row. Hang on a sec. Now if I click this, row number 5 gets directly connected with row number 7. So once again we put this one. So positive through the resistor, through the switch, then onto the positive one of this LED, and finally taking it from 8 all the way back to all the way back to the source. Okay, so when I press this, as you can see, we got a circuit there, through the button, through the LED, back to negative, and then back to negative. So when I press this, this should turn on. Alright, I'm glad I didn't screw that up. Yeah, this is interesting because I want to show you the difference between whether it's in series or parallel. So right now, this is they suggest 2 of these switches and put them in series. So as you can see, it goes through the resistor, through one switch, then the other switch, and then on. So, same thing as before. Let's just take out this, and put in an, and take this switch. Take this jumper and connect that there. And connect another switch. Okay, that's it. And then, okay, yeah, so. And then just keep it going down one more. And then connect this switch, this LED, press the positive once again, and then connect the other end back to the ground. So that way, switch over there, electricity goes over there, then through this switch, across this connection, through this other switch, across this connection, and through the LED in there. So if we press this switch, nothing happens. If we press this switch, nothing happens. But if we press both, oh, sugar. Okay, I see what I did. I accidentally connected the thing to the positive rather than to the negative. That's kind of silly of me. Give me a moment to fix that up. That's good enough. So this, nothing happens, nothing happens. Yay! So this is what it means by series. One after another. It's only when they're both down does it go on. If one is the other, not the other. Okay, so let's go on to the parallel one. This is where basically we connect one switch and then it goes, and then the other switch and it also goes. So basically, there's 2 paths to it. This resistor comes in here and it switches this one. Oh yeah, it's here. Okay, so. So on this one, let's just take this out here. You see, right now this switch is fed directly by the other switch. But, screw it, I'm gonna get this out. Yeah. So we take, instead of connecting the positive of this switch directly to the output of this switch, we connect it to the positive of the, oh, sugar, accidentally made it, well, not quite a short circuit, but something along those lines. There we are. Come on, you piece of electronics, you. Yeah. This is what an engineer is all about, trying to keep getting it working even though it should be really, really simple, and you shouldn't, or are you just, okay. Okay, so that by itself is kind of like a basic switch. You know, it goes straight from there. But now we're going to try to connect it so the output of this also goes to the same place. If you excuse me. Okay, that's not long enough. This really makes you use the wrong colors. I like to keep things, you know, the right colors, like if it's positive, you know. But anyway. Okay, so there we have it. So now the output of this goes to the start, and so does this. So when I press this one, it's on. If I press this one, it's on. If I press both, it's also on. What were you expecting? So as you can see, this is the same sort of diagram as the connection in parallel. There we are. That's the intended effect. This is what we actually got. And as you can see, there's this little diagram thing that shows us that, you know, basically the switches are right beside each other technically, and it doesn't matter as long as at least one of the switches is down. The light is on. That's technically known as an OR gate. Anyway. Okay, and that seems to be a bit. Oh yeah, there's some stuff about Ohm's law. I or V equals I or squared. Just remember that and you'll figure it out. Oh, and there's a multimeter. So that's chapter 1 complete. Not chapter 0 because that was getting started. Getting to know your tools, and the next one is about a spaceship interface, although I think it's just really a traffic light. But the point is, it's really exciting, and stay tuned, and hope you enjoy.